Okay, again, my name's Steve Willoughby with Bentley, and I've been a part of our bridge group here within Bentley since its inception nearly 10 years ago. It was in January of 2008. And I'm really excited here today to talk about OpenBridge Modeler and how it will work with our analytical software products. So let me go ahead and kick that off. Um, and the one thing I really want to talk about is the fact that we have now one bridge model that can be used for the entire life of the bridge. And we'll see a small portion of that overall process here today in this 20 to 30 minute presentation. So we're going to take a look at modeling or taking the model of either a precast girder bridge or even a steel girder bridge. I'll actually do both here and take that model and transfer it on into our analytical products. And then maybe make some changes to that model while we're in the analytic products, and then send that back to OpenBridge Modeler so we can update that model and keep that physical 3D model that we have in OpenBridge Modeler and our analytical model synced up and show you that process. Up until now, things have been very disconnected. I used to work for an agency myself for about 10 years, and I know the roadway folks had their own information, the bridge folks had their own data, and even talking to a lot of agencies today, that's still very much the process out there. And even consulting firms for that matter, the bridge folks don't really talk to roadway and vice versa a whole lot. And so we may be upsetting the apple cart just a little bit here by giving you the ability to share information with each other. And it really doesn't make sense to start over on a lot of these things. So as far as looking at kind of how everything's integrated here, essentially OpenBridge Modeler is right here in the middle because it's going to be the one product that's going to talk to just about everything else out there. It can talk to the roadway design software, whether it's Geopack or InRoads or OpenRoads Designer. Um, we can get alignment and profile information from those products, train model information, super elevation information, among others. And then it'll also talk to, like I said, all of our analytical products. So depending on the type of bridge that you model, it's really a one button click away to send it to the analytical products and start the process of doing the analysis and design. And then, of course, works with our ProStructure software for detailing as well. And then the combination of these uh, will work with, of course, our MicroStation, our visualization software, LumenRT, our collaboration software being ProjectWise, and then our operations and maintenance products as well. But today we're going to focus on this portion of the overall diagram here, being able to take that bridge model, send it to the LEAP products, make some changes there, and then bring them back. So again, I want you to kind of think of and keep in mind that we're really probably the only company out there. We are the only company out there that offer the ability to create one 3D parametric MicroStation-based bridge model and share that with everything else that you would ever need to share it with. We do kind of bridge that gap between the roadway engineers by allowing the bridge folks to simply reference the alignments and profiles and reference the terrain model. That way, if a change is made to, let's say, a profile or a terrain model, the bridge will automatically inherit those updates and can change geometrically based on any of those changes. We can use, like I said, that one model for analysis and design, and we'll see that today. We can send this send this to any of our bridge-specific analytic products. We can do steel and concrete detailing from this one model. We can prepare quantities and cost estimates from this one model. It's a nice benefit, I guess you could say, that we get from being in a MicroStation-based platform is that automatically get things like quantities and that from it, as well as things like geometry, verification, constructability. We can check clearances, either horizontal or vertical or both. Management of project changes, being able to go in and very easily make changes to the structure while we're in OpenBridge Modeler is certainly one of the highlights of the product. And then the ability to plan and manage construction, things like access roads, staging, and scheduling. Now, as far as The OBM modeling process. I'm not going to actually model a bridge here. We have we've done a lot of webinars on that and a lot of videos, but basically for those of you that haven't seen it, we start with an alignment and profile. We add some pier lines, we add a deck, and then we go through and we'll define the beams on the structure, and then we go about adding the substructure items. So piers, abutments, bearings, wing walls, those sorts of things can be added. And then finally go in and add barriers. We could potentially add 3D cells to the model as well. So if we look at it from a steel girder bridge modeling point of view, within OpenBridge Modeler, we can do simply supported or continuous beams. The beam paths can be concentric to the alignment. They can be completely independent of the alignment. And that's on a beam by beam basis. Each one could be totally independent. Standard rolled shapes, built-up plate girders are all there. We can define the beam locations relative to the piers, and I can show you on the model that I have today how we've done that. And then the girders can have linear, parabolic, or circular haunches for the webs. And then we can also go in and potentially add cross frames and stiffeners to that model as well. And in the end, it's literally kind of a push of a button and sending it off to LeapBridge Steel. So what can we send over there? Well, again, it's a two-way data exchange with the Leap products. So it's the deck, the built-up girders, rolled steel girders, the haunch, the material properties, and then all the substructure properties go over to Leap Steel as well. The way we do that, there's an interoperability tab where you'll select LeapBridge Steel here and you'll pick export. It'll pop open a window just briefly and you'll say okay. That will go ahead and open the LeapBridge Steel software, allow you to make whatever changes you need to make there, do your analysis, run your optimization, whatever you want to do. But any changes that you make there, we can export an XML out of LeapBridge Steel. So there's an OpenBridge Modeler tab here where we can export a XML file back to OpenBridge Modeler. And then once we're inside OpenBridge Modeler, we can select that file and ask it to go ahead and update the model and accept those changes. And that's kind of what this window looks like. And we'll see that live here today as well. LeapBridge Concrete, basically the very same process. Two-way data exchange, deck, the girders, the haunches, all the material properties as well as the substructure as well. Very same process. There's an icon here devoted to LeapBridge Concrete where we can send the bridge to it. That'll go ahead and open up the LeapBridge Concrete application there on your desktop and allow you to make any design or geometric changes while you're there. To export the information back to OpenBridge Modeler under the Tools pull down, you'll select OBM Sync and send to OBM. Again, that will also create an XML file, and then we can accept the changes from there on the OpenBridge Modeler side. So let's take a look at this live. So I'm going to go ahead and open up a model here. So this is a steel girder bridge model, and this is one of the models that we actually use for our training in Virginia DOT. We've done a lot of training with VDOT, and we use some of their design examples here. So this is a three-span steel girder bridge that we model as part of as one of the 3 different bridges we do as part of a 2-day class for VDOT. So what I want to show here is I'm going to see we've kind of pretty well got it modeled here. I'm going to go to the Interoperability tab, and I'm going to select LeapBridge Steel and say I want to send it to LeapBridge Steel. And you give it just a second, and it pops open a window, and it says it's going to create a file. It's going to put it in this folder. It kind of takes care of naming all that for you. You simply pick OK, and behind the scenes, it'll go ahead and create a transfer file, and then go ahead and open up the LeapBridge Steel software and open up LeapBridge Steel itself. So there it's opened up the LeapBridge Steel software. We can see it's brought the identical bridge in here. Kind of spin it around, take a look at it. And just to show you, what I'm going to do is I'm simply going to come here to member definition. And for those of you not familiar with LeapBridge Steel, this is where we can go in and make changes to the sizes of the plates here. So for example here, this is the web plate. for member 1 here. And I'm just going to go in, I'm going to change the size of it to, let's say, a 42-inch beam. Now I can do that one field at a time here, kind of like you see me doing here. Or the other way we can do it, and I need to do it here at the end, is I can select all 3 items here in this, and then just type 42 once and press enter, and that will change all 3 here at the same time. So a really neat little trick to know here within LeapBridge Steel, especially this member definition window. So I'm going to go ahead and say I want to copy this from beam 1 to all the other beams. So this change in height here, and pick OK. And then I need to give it just a moment, and it's going to update the bridge model here for me. So I've now updated the bridge model, so I now have 42-inch girders, which we can't really tell much by looking at it from the side here. But what I am going to do is I'm going to tell the software that I do want to go ahead and send a file back to OpenBridge Modeler. So I'm going to go ahead and say, well, I want to save a file here, and let's just put it right here in this folder. And I'll just overwrite the one that's here, this LeapBridge Steel to OBM. Actually, you know what? We'll go ahead and create a new one just so you see it's real. So I'm going to put a TT on the end of this for our tech talk and save that. Lets me know that that transfer happened okay. And now all I really need to do, I can just minimize this out of the way for right now. But again, at this point, there isn't anything you couldn't do here. This is a pretty complete model. Basically, we would just need to add cross frames, stiffeners, shear connectors as needed. You could define your field splices here. You could add appurtenances like barriers and medians in that, and then jump on down here to the analysis and run analysis on it. And just so everybody knows, this is the latest version of Leap Steel, although there's a new one probably coming out next week. But in this version was added the ability to do finite element modeling here as well, in addition to, or analysis, I guess finite element analysis, in addition to line girder and grillage. Okay, so back to OBM. We've saved our file off to OBM. I'll minimize this out of the way. And on the OBM side here, I'm just going to come in and pick LeapBridge Steel, but this time pick Update. And now I need to go to the right folder, so I'm going to go up a couple folders, go to my steel girder folder. Okay, so there's the file we created just a moment ago. So I'm going to go ahead and open that up. And we need to give it a moment, because what it's going to do is it's going to compare the information in that XML file with what's here in OpenBridge Modeler. And you notice the only thing that came up different is the beam section. And if I scroll down a little bit, we'll see what those differences are. So essentially, the biggest difference being in OBM, currently the beam has a web of 39 inches, and it's going to now be 42 inches. So I'm going to go ahead and I could either hit accept all, or I can accept just that one, since everything else here is the same. So I'm going to go ahead and pick OK, and then give it just a moment, and it will go through the process. And basically, it has to recreate the model of this bridge, because now that these beams have a deeper web, it's going to change the cap height on all my piers and abutments, and just force a change throughout the entire model there. And just to verify that those changes took place, if I go back to, let's say, my Project Explorer here, and I want to verify that height, I'll come here to the Beam Group tool and select its properties and tell it that I want to edit the beam definition. And now I can see for the web here on this first beam, I do in fact have 42-inch high webs for the full length of the girder here. So just to show you that we did literally kind of round trip all that information. So really, any geometric changes that you make on, let's say, the LeapBridge Steel side while you're in there, whether it's the web, the top flange, the bottom flange, any other geometric changes you make there, those can be sent back to OpenBridge Modeler here and updated, as you can see, very, very quickly. And again, we're just trying to keep that physical 3D model that we have here, and that analytical model there in Leap Bridge Steel synced up at all times. Okay, so let's take a look at the same process for, let's say, a precast steel bridge. So I'm going to go, or precast girder bridge. So let me open a different model. And this is another one from our VDOT training class. It's a pretty straightforward two-span straight precast girder bridge. And so I'm going to send this to Leap Bridge Concrete. So I'm going to come here to the Leap Bridge Concrete icon here on the Interoperability tab. So I want to send it to that. And just as we saw before, it's going to go ahead and pop open a window and suggest a name and location of a file to create. And I'll just go ahead and accept that and then wait for it to open the Leap Bridge Concrete software. Okay, so it's sent the bridge over here. We can go to the geometry tab and see that, in fact, we do have a 4-span precast girder bridge. I'm going to go ahead for the changes this time. I'm going to be a little more involved here. So I'm going to go to the superstructure tab and open that module. And we can see we have all the information here. I'm going to go ahead and say add some curb information here on both sides. Here under materials, I'm going to try and mimic a little bit of the information that was used in the actual design of this structure. So I'm going to go through and change some of the material properties and the pre-stressing tendon that was used, as well as add some basic loads here for future wearing surface and the curbs. So we have something in there. And then I'm going to go on to the beam tab and have it define the strands for this. So I could either use the wizard to do that, or there is an auto design tool here. I'll just go ahead and auto design this real quick, see what it comes up with, and then I'm going to use the wizard and make just a few changes here. And these are all things that can be done pretty easily, as you can see here with the wizard. And I'm just trying to make this a little more like what was in the actual plans. And I'm trying to remember exactly how many strands there were here. Something akin to that. And let's select OK. And that has satisfied our design status here. And I'm going to go ahead and copy this to all the other spans and beams and use the strand pattern. I know it's not perfect, but it gives us something to work with here. And as part of this, it also comes up with what? Well, it helps come up with some initial camber and deflection information here as well. So I'm going to go ahead and OK that. So we've made several changes to the beam here. We've made some changes here in material, and then by adding the strand pattern, we've come up with and kind of forced it to do some camber and deflection calculations. So when I close this, it's going to ask me, do I want to go ahead and update my Leap Bridge model? I'm going to go say yes, and say no to, I don't really need any reports at this moment. And it updates the diagram here and shows me where the strands are at various points along the beam. And now what I can do is I can go back and say, well, let's say I want to send these changes back to OpenBridge Modeler. And again, I could have changed the number of beams here, the beam spacing, the actual girder shape itself, maybe went with a different size girder. All of those things are very possible during the actual analysis and design process. So I'm going to tell the software here that I want to go ahead and create a file and send it back to OpenBridge Modeler. And I'm going to put it in this folder. And again, I want to make sure I create a new one. So I want to put a TT in here and save that. And when I minimize that out of the way, now back in my OpenBridge Modeler file here, I can come in here and say I want to update the model here. And I'm going to go ahead and select that file I created just a moment ago and go ahead and open that Oh, that's the wrong one. Let's see, PCBT. There we go. So Leap Bridge Concrete one. Open that up. And now it's, again, it had to compare what's in here versus what was in that XML file. And it recognizes there are some differences here. So if I go to beam section, it tells me I have a different beam section, but the actual differences are in the strictly in the material properties here. So not a big deal, but it is something we can bring back and forth. But my primary reason for doing these changes here is I do want to show the ability, the fact that we can bring camber and deflection information from Leap Bridge Concrete back to OpenBridge Modeler. Okay, so again, we get to select what changes we want to bring back in. So we'll bring back that camber and deflection information, and that really doesn't have an effect on the physical model here as far as what we see, but that does have an effect back here in the reports menu. So if I go back to reports, you'll notice there's a camber button here. So this was added to the latest version of OpenBridge Modeler back in July. And this allows you to either input the camber and self-deflection and any additional deflection on the beams, or you'll notice there's an icon here at the top where it says, go ahead and get that from Leap Bridge Concrete. So if you've already done all your analysis and design there in Leap Concrete, it's simply a matter of just tick that on. It's going to bring in that camber and deflection information for all the beams for each span here and show us those values. And then I can go ahead and generate a report here. So I'm going to go ahead and submit that. I'm going to let it do this at the 10th points. So here I am for my leftmost beam. It tells me what the input camber and deflection was. And then it shows me, okay, here's my locations at the 10th points. Here's my final deck elevation, my screed elevations, girder top, and then screed height above the girder, all the way along, again, at the 10th points of each of the beams here. And now that I have this report, this is something we can save off to spreadsheet. We can save it out as a CSV file, a text file, even a PDF. Either save it locally or email it to someone as any of those same formats here as well. Okay, so that covers the bulk of what I wanted to show here today. Again, we took a model here in OpenBridge Modeler, both a steel bridge model and a precast girder model. We sent them to the respective analysis products, made some changes while we were there, and then sent that information back here to OpenBridge Modeler and synced this model up. And you can do that multiple times. Okay, you can start through the process of doing the analysis, and then if a change needs to be made, you can come in here and make whatever changes you need to on the OpenBridge Modeler side, and you can resend it back to either Leap Concrete or Leap Steel, or RM Bridge for in the case of segmental bridges. So if you came in here and said, well, gee, I need to change the location of the beginning of the structure here, you could key in a new station, key a new skew angle, and go right back to that interoperability button and resend that to the analytics software. And it retains the loads that you've put in previously and simply changes the geometry based on whatever changes you make in here. So it is a two-way street, if you will, of the ability to send this information back and forth multiple times. So with that, I'm going to go ahead and stop there. Let's see, we're about 26 minutes in, and open this up to any questions anyone may have, and either myself or Alex would be glad to assist in helping answer those questions. So feel free to type in any questions you may have in the chat window there, and we'll be glad to help you out.
Thank you, Steve. Hey, questions are coming up. Okay, let's see. We have first one here. With the model be reporting the screed elevations, and is any move that you are aware that to use the automated grading machines to assist in the construction of the structure?
Yeah, we are giving those screed heights out there. So, and again, you could save those off to a spreadsheet or whatever format makes it easiest for you to get those to a any type of an automated machine for paving later on. Absolutely.
Okay, perfect, perfect. Now, I've got another one here. Um, so far, what's the other type of bridges that we can model and send it to the analytical solutions?
Okay, so we talked about precast girder and steel girder here. If I go back to bridge setup, and this is probably the most common place to see it, is when you start the process of modeling a bridge, one thing you have to tell it at the very front end is what type of a bridge do you have. And so the first option here is our pre-stressed or reinforced concrete girders. Option 2 here is steel girders. But we also have a reinforced concrete slab here, which would go to the old Combox software that's within Leap Bridge Concrete. There's a cast-in-place concrete box. Again, that's part of the former uh, Conbox software that's in Leap Bridge Concrete. And then we can also do segmental bridges. So those are the 5 types of bridges that we focus on today.
Okay, perfect. And it goes with the next question, or more or less an assessment that says what other type of bridges can be used, like pedestrian, light rail, freight. So really, you can use it for any kind of bridge that adequates to these type of beams, because you can create your own beams, right? And adequate it to maybe a heavy steel bridge for a light rail or a heavy rail project. So all these types can be
Absolutely.
modeled,
Yeah,
and yeah.
yeah, we've had people model all types of bridges. We've seen some very creative uses already. Because you do have the ability, there is a libraries tab here on the back side of, or near the end of the tab menu here, that allow you to go in and define your own decks, your own barriers, your own beams, your own column shapes, define your piers and abutments, wing walls, stiffeners, cross frames, and so forth. So there's really no limitation there as far as uh, what you can define today. And like I said, we've worked with a lot of agencies and consultants so far, and I've done a lot of on-site training for both as well. And typically at the end of class, we'll take one of their structures and go ahead and model it, and it's worked quite well for really any type of structure we've tried to model today. So again, very excited about the fact that we have this. Runs at a microstation kind of platform, yet talks to, like I said, all of our analytical products and detailing products in that. So it's really, you model it once and then reuse it over and over and over as much as you can. So anything else out there,
Now,
Alex?
yeah, oh yeah, yeah, yes. I mean, question keep coming up. Now, for you, what would you consider was the biggest advantage of using OBM?
Actually, I think I just said that, but just the fact that we have that one model, right? The fact that we have that one model, and things are, like I said, very easy to change in here. If I want to make changes, for example, to this pier, I simply come in, I can click on it, hover over it for just a moment, select its properties here, and I can go in and change just about anything about it. I can change these elevation constraints, for example, which would be the elevations at the top of footing there. Those can be based off of either a terrain model, or I can go in and give it a hard elevation here. So for example, if I zoom in and snap to these right now, they're currently around an elevation of 413 point something. So if I wanted to change them, again, I can come in simply to the properties here, go to the elevation constraints, footings, and let's say I want to, so I can make them relative to a terrain model, and I could say just make this maybe 4 foot below the terrain model, and hit apply all and OK, and it would adjust based on the terrain model. Or I can just give it an actual elevation here. So let's say I make this 410, for example, and apply that. And then when I select OK, that will go ahead and update the model that easily. So, and that's true of everything else here, for example, on this pier as well. So if I go to the substructure template, uh, it's all done parametrically here, especially for the substructure items. So it's going to open up a view here and show me the current dimensions on the cap, the information about the columns here, about the footing, and well, right now I don't have any pile under here, but we could change and add a pile arrangement. But it's really a matter of just kind of filling in the blanks here and selecting OK, and letting it, letting us take care of creating these 3D elements for you. And at any time, you can add any of these to your library. So if you need this for a future project, you come in you pick Add Library, give it a name, and you can continue to reuse it on other projects.
Perfect. So, yeah, and it goes with the same question. I mean, because some another user was asking, then what's the difference between this bridge modeling in OBM and this parametric modeling that you can do in LibBridge, for example? And I think you just highlighted the difference big time, right?
Right. Yeah. Exactly. So.
There's another question, but that's on the analytical products, that if we can perform seismic analysis and design.
Oh, sure. Yeah, we have on the LeapBridge concrete side, we just recently added, I believe it was that this summer, Alex? We added response spectrum analysis here as a part of LeapBridge concrete. So if I go back to, well, actually, it's going to show up here in a future version, or in this next version. But we do have response spectrum in here. Let me go back to precast pre-stressed girder icon here for just a moment. And in the wizard here, there's an option here to include these masses for response spectrum analysis, and it's actually a toggle up here. But then that's also a part of the analysis portion as well. So if you go to the substructure portion, we've added, like I said, response spectrum there. And I did a video on that, or did a presentation on that, or a tech talk. Actually, it was probably my last tech talk about 2 months ago. It was about 30 minutes or so on response spectrum analysis. So
and there is also and there is also a YouTube video on our YouTube page, YouTube channel, on just response spectrum with LibBridge.
Exactly. Yeah, that's a good point. We, Alex and myself and a couple of other colleagues have been working pretty hard this past quarter, and actually probably this next quarter as well, adding a lot of videos. We have a YouTube channel for our various bridge products and that. So feel free to do like a quick little search on YouTube there for like Bentley bridge analysis, and that'll bring up our YouTube channel. And we have a lot of videos out there on Open Bridge Modeler, Leap Steel, Leap Concrete, and Bridge. So
there are more than 100 already.
Are we really? Wow. Okay.
Oh yes. Yeah. Now another question here: if you have custom beam sections that you model in OBM, will that show up automatically on LibBridge concrete, or how is it going to work?
Oh, good. Very good question. And we've actually kind of run into that in Virginia a little bit. So for example, here in Leap Concrete, or I'm sorry, in Open Bridge Modeler, you can define your own beam shapes. And we have beam shapes out here for various agencies that we've defined maybe here, but we don't have them necessarily in Leap Bridge Concrete. So whether that's VDOT shapes, we've got some TxDOT ones, we've got some of the new IDOT shapes out here and so forth. Those are all in here. And if they're only in Open Bridge Modeler, it will still send the bridge over just fine. But what will happen on the Leap Bridge concrete side, once you get in here and you go ahead and go to pre-stressed girders, it will go ahead and kind of automatically add that beam shape to the library. But then as the user, what you will want to do if you're actually going to go ahead and do design is you'll need to come in here. For example, if it's an eye girder in this case, so let me scroll down. Fine. So there's that same eye girder in here. And it would just take whatever you named it in Open Bridge Modeler, and that would be the name in here. Worst case, if you don't already have it in here in Leap Bridge Concrete by the same name, you would probably need to come in here and modify this. And the main changes you would need to make would just simply be under this template area here, where you go in and define where what we call our strand template is. Where can the strands be located on this beam? So, for example, for these VDOT beams, they start 2.5 inches from the bottom of the beam, and they go all the way up to within 2 inches of the top. And there's a nice little auto-generate tool that makes it very simple to go in and add those template locations. And once you do that, then you can go ahead and work through the process here of doing the design on the beams. But that's really about the only thing you'll need to do. Otherwise, it will send those beam shapes over just fine.
Okay, great. Now well, that's kind of an easy question now. Will this software work with MicroStation Connect? Right?
Okay. We are in the process of porting OpenBridge Modeler to the Connect platform. So right now we are still based on the V8i based platform of MicroStation, but we are actively working on that and should have that probably around January or so of next year.
Yes.
Is what they're now saying for the Connect version of OpenBridge Modeler.
Yeah, and just to add, it doesn't need MicroStation to run because it runs on the Power platform, right?
Right. So yeah, you install the software. It's has MicroStation plus a fair amount of the roadway design software, because, like I said, we have all the horizontal alignment, vertical geometry, terrain modeling, and super elevation tools.
I think so far what you cannot do is just corridor modeling, but it has everything else.
We have a lot of the basics here.
Yep. Now, I got another question here. Is OpenBridge, what is better, according to this question, what is better, to do drawing generation with OBM or use the drawing generation that is in Leap Bridge Concrete?
Probably the ones here in OpenBridge Modeler, because these are going to be more MicroStation based, I guess. Let me see. I don't really know if I have. Here's some.
Yeah, guess what? The difference in general is that these drawings that Steve is showing on the screen, they are coming straight from the model, cut on the model, wherever you want it, really. And is the true beam cut, I would say. In Leap Bridge Concrete, yes, there is some drawing capabilities, but I would say they are limited on the sense that it's more of a schematic view. Don't get me wrong, it's come from the model, but it's more of a schematic view from the analytical model that you have done. This is from the true model. So the workflow, even though both are valid, but the real workflow should be what Steve is doing, cutting the sheets from the OBM model.
Right. These are using true dynamic views
yes.
to do the modeling for us.
The other is static. So
yeah, we're getting a little bit of feedback.
Yep. Now, what about the reinforcing detailing in 3D? Can OBM do it?
Yeah. Yeah, we do have the ability here under interoperability to tie this model to our ProStructure software. So we can certainly do that type of modeling. Let me go back to, and I don't have that installed on here, but let me go back to my PowerPoint real quick. The video I have there actually kind of demonstrates how this would work. So we'll go ahead and kick this off. So here's an OpenBridge Modeler model. Not terribly different than anything we've been looking at so far. But here I've gone ahead and opened it up in the ProConcrete software, and that's our reinforcement detailing software. So we were careful to work with the developers of ProConcrete when we created OpenBridge Modeler to ensure that the elements that we create here are compatible with ProConcrete. So you'll notice here they can literally go out and kind of select a pad real quick, select the pad tool, select a graphical element here, and just walk in and very quickly add some mat reinforcing to the top and bottom of these pads. And there's a special column tool as well, so you can go in and select a column, and it will go ahead and add the reinforcing to that column.
Yep. And the model is a reference file, right? This is not the live bridge. That's the
Well,
beauty of
right,
that.
right, yeah. This is kind of referenced in. So if we go back to, for example, here we've after that reinforcing was added, gone back to OpenBridge Modeler and said, you know what, let's make a change to those pier elevation constraints we looked at a moment ago. So now it's changed the length of these columns and the locations of where those footings are located. So if we go back to Pro Concrete here and we update that reference, because now it needs to be reloaded. So go ahead and ask it to reload that reference. We can see once that reference was reloaded, it automatically recomputed and redrew all the reinforcing there to sync back up with that model. So,
exactly.
and then here they're using just the generic dynamic view capabilities of MicroStation and going in and cutting a section through that pier, and then showing you that we have labeling tools in that where we can go in and very quickly add a label to any of that reinforcing in this 2D model here. So we not only draw the bars in 3D, but we can show them to you in 2D and do all the labeling as well. And if you make changes to the reinforcement in the model, that will automatically update anything we see here, because these are dynamic views. It's like a very special reference file. It's a live reference through that model there. So
Great.
hopefully that kind of helps you understand what we can do there with the Pro Concrete software.
Perfect. This is a structural question. Can Leap Steel analyze curved structures?
Oh, absolutely. Yeah, there was a kind of a misconception there for a while from some folks, but absolutely, we can do both straight and curved structures with Leap Bridge Steel, and we can now, in this latest version, do tub girders as well. So we should be able to handle both straight and curved eye girders, rolled shapes, or tub girders equally well.
Yeah. Yeah. And all the other extra elements like shear connectors, stiffeners, cross frames, feeler splices,
Absolutely.
and
Yeah.
rating as well.
Yeah. We do all the analysis on all that and all the code checks there as well. So very, very thorough steel bridge design software at this point.
Okay, so now how are we doing on time? I think we're okay still. Got a couple of questions coming up.
Okay, yeah, we'll probably do a couple more here.
Okay, yeah, there is one that says how we interface these with Autodesk products.
Well, I mean, as far as the CAD model itself that we have here in OpenBridge Modeler, this is really just a DGN file. So really, Autodesk products should be able to open up a DGN file just fine. You're still going to need OpenBridge Modeler if you want to make any intelligent changes or updates to the model here. But really, it's just a MicroStation drawing that you could open up with anything else that can view a MicroStation drawing at that point.
Okay. Oh, awesome. That was a repeated question. Perfect. Now, what is the difference now? This is kind of a product question. What is the difference between LeapBridge Enterprise and LeapBridge Concrete?
Well, there used to be a product called LeapBridge Enterprise, and about a year and a half ago or so, we basically just renamed it to LeapBridge Concrete because it was a little confusing once we added the steel product in there. So essentially, as far as the Leap products go, we now have a LeapBridge Concrete and a LeapBridge steel product. So the concrete one being focused on concrete superstructures, and the steel one, of course, on steel superstructure. Both of them basically have the old RC per product underneath there for doing the substructure analysis and design still. So
Okay,
Enterprise
perfect.
was just renamed to Concrete a couple years ago.
and we updated the code with that. So you should be designing, if not a very old project, you should be designing with Liebridge Concrete by now, right?
Yeah, that's a good point. Enterprise, the last version of that had the 6th edition of the spec in there, and we're now up to the 7th edition spec with 2016 interims in it, and probably the 2017 interims for the versions coming out next week. So sometime probably next week there should be new versions of both the concrete and the steel products being posted to Select Server.
And the code between the 15 and 16 has changed a lot, especially, for example, I was studying the wind analysis. It has changed completely the requirements and parameters. So if you got this kind of project, and kind of newer project, you should be designing by now with Liebridge Concrete.
Yeah.
Okay. Maybe the last question.
We're kind of, just to make everyone aware, we are in the process of shooting for about 3 to 4 releases a year. So being pretty aggressive on the timeline there as far as doing releases. So a little bit smaller, a little bit less added to each release, but a little more timely as well. So yep. Hopefully that's working out well for everyone.
Yeah, especially with keeping up with the codes.
Right.
Now, maybe what could be the last question here, can the software compute camber diagrams?
We hopefully kind of showed that earlier, but yeah, we do have, we don't really draw the diagram per se, but we will give you all those camber computations here that we can generate here in this report menu. So again, we can do the final deck elevations, the screed elevations, girder top elevations for the erected girders, and then the screed height above the girder. So helping you get all those set out in the field for pouring the deck.
Yeah. And also in the steel, we give you, the camber diagram itself, right? When you design with Leap Steel.
Right, exactly. You can get a similar type of report out of Leapbridge Concrete as this, but as Alex said, on the Leapbridge Steel side, we even give you some more. We'll actually draw the diagram itself and give you a breakdown at the 10th points of each of the loads that, and you as the designer get to elect or select what loads to consider for the camber itself. So it gives you even more control there.
Okay, just kind of a statement here from one of users that says that yes, Leap Steel and Leapbridge Concrete are analysis programs that you can analyze it, design, run code checks, and yeah, you can do iterative design because you can just change options in Leapbridge Concrete, Leapbridge Steel. Changing the spacing of the beams, the number of beams, the type of beams, and redesign if you want. So the Leap Steel and Leapbridge Concrete are design and analysis software that I would say allow iterative design. So.
Well, yeah, and especially on the steel side, we have some design optimization tools there as well to help you size those, help with the plate sizing and that, and coming up with a more optimal design.
So, okay, I think we are up. Last question to answer was, can we import information from inroads? Yes, we can import from inroads, from Geopack, DTM, and geometry files. So that's it.